Hello, today we're going to look at solving a system of equations using substitution. Now when you think of substitution, what I want you to think of is taking something out and putting something in its place. So again, substitution. Think taking something out and putting something else in its place. Now, when using the idea of substitution, it's used best when the variable of either equation is isolated, meaning it's alone. So the whole point of this is to use the secondary equation to find the solution to the other equation. So let me show you what I mean by that. Here we have y is equal to 9, and then we have our secondary equation, 9x minus 10y is equal to negative 18. Well, here this first equation is already solved with one variable isolated. And I'm telling you what the value of that variable is. It is 9. So what I'm trying to do is I'm going to use this line to find out what this line has as either an output or an input. So remember a couple of things. X is your input, your domain. It could, your input or domain. Your y is your output, your range. And what we're trying to find is where do these lines intersect? Because remember, where they intersect, that's the solution to our system of equations. So this time we're just finding the solution in a different way other than graphing. We are going to actually solve an equation. So here on this one, I know that y is 9. So what I'm going to do is I'm going to substitute where I see y, I'm going to put 9 in its place. And now I'm left solving for x. So 9x minus 90 is equal to negative 18. I know I add 90 to both sides of the equation, and I've got 9x is equal to 90 minus 18 is 72. I know it's positive because my larger number is positive. I'm going to divide by 9 on both sides of the equation, and I've got x is equal to 8. So the intersection of the lines, or the solution to this system of equations, is going to be the ordered pair 8, 9. So I'm saying when I input 8, I get out 9. So now we have y is equal to negative 4. So I'm going to do the same thing. Where I'm looking at my second equation, where I see y, I'm going to instead put in negative 4, and I'm going to solve for x. So 5 times negative 4 is negative 20. equals 8. I'm going to add 20 to both sides of the equation because I'm eliminating 20. And I have 7x is equal to 28. Divide by 7 on both sides of the equation. X, therefore, is equal to 4. So move this up. I didn't realize you guys can see that. So my answer to this system, or my solution to this system, is 4, comma, negative 4. I'm going to put a box around this so I can use this page. So now let's look at number 3. We've got x is equal to negative 10. And then my secondary equation is negative 8x plus 7y is equal to 17. And just like I did here with the y, I would take the letter y out and substitute the number in its place. I'm going to do the same thing here. For this equation, I have negative 8, but instead of writing x, I'm going to write the value of x, which is negative 10, plus 7 multiplied by y equals 17. So negative 8 times negative 10 is positive 80, plus 7y is equal to 17. I'm going to subtract 80 from both sides of the equation, and I'm left with 7y is equal to, let's see, 63. But it's not positive, it's a negative 63 because negative 80 is bigger. Divide both sides by 7. Y therefore is equal to negative 9. So my solution to this ordered pair would be negative 10 as my domain or my input, negative 9 is my output. Let's go ahead and look at number 4. I have x is equal to negative 1, and my secondary equation, or my secondary line, is 3x plus 3y is equal to negative 15. Well, where I see x, instead I'm going to write negative 1 plus 3y is equal to negative 15. Got negative 3 plus 3y is equal to negative 15. This time I have a negative 3, so to eliminate my negative 3, I'm going to add 3 to both sides of the equation. I've been dealing with inequalities a lot. So I've got 3y is equal to negative 12. I know that because negative 15 is bigger, and it has the advantage by 12. So I divide by 3 on both sides of the equation, and I've got y is equal to negative 4. Therefore, my solution would be negative 1 as my x value in the ordered pair, and negative 4 as my output value. So negative 1, negative 4. Alright, so again, we're still solving using substitution. For number 5, they just changed the way the question is worded. They put the standard form equation up top. So we've got 5x minus 10y equals 10. And the secondary line is y equals 4. If you remember, this is a horizontal line if you were graphing it. So now I'm going to do the same thing I've been doing. 5x minus 10. Where I see y in the first equation, I'm going to replace it with the value of y of the second equation. So 10 times 4 equals 10. So I've got 5x minus 40 is equal to 10. To solve the equation, I'm going to eliminate negative 40 by adding 40 to both sides of the equation. And I've got 5x is equal to 50. Divide by 5 on both sides of the equation. I have x is equal to 10. So the solution to this system is 10, comma, 4. That's where both of these lines cross. Let's look at number 6. We've got y is equal to negative 7. The second line is negative 10x minus 7y is equal to 19. I've got negative 10x minus 7. I'm substituting the value of negative 7 for y equals 19. So I've got negative 10x. Negative 7 times negative 7 is positive 49 is equal to 19. I'm eliminating the 49. So I would subtract 49 for both sides of the equation. And I've got negative 10x is equal to negative 30. Divide by negative 10 on both sides of the equation. X therefore is 3. And so the solution to this system would be 3, comma, negative 7. So question number 7, the form is a little different. However, the process is the same. So we're just using substitution. We've got y is equal to x plus 4. And in our secondary equation, we've got y is equal to negative x plus 10. Well, we know from the first line that y is equal to this entire amount or quantity or line in this case. So if y is equal to x plus 4 up here, when I see y in this second equation, I can substitute the value of y in the first equation for the value of y in the second. So now I've got x plus 4 is equal to negative x plus 10. And we just solve by getting all the values of, in this case, x on one side of the equation and the numbers on the other side of the equation so that we know the value of x. So since this x is positive, I'm actually going to eliminate the 4. So I eliminate 4 from both sides of the equation, and I'm left with x is equal to negative x plus 6. I'm still not done because I have an x on this side of the equation. Now, if you'll remember the hint that I gave you last year, those of you who weren't with me don't know this hint, but I'm going to give it to you now. Whenever you have what we call an algebraic expression and you have a numeric expression and you're solving equations, when you get down to one of either the algebraic or numeric term, don't continue to move that term back and forth. Just leave it. You want to deal with what you have two of. So in this case, I have two algebraic expressions and one numeric expression. So I'm going to leave the numeric expression alone and I'm going to move the algebraic expression. So I'm going to add x to both sides of the equation, and I've got 2x is equal to 6. Now I just solve for x by dividing by 2 on both sides of the equation. X therefore is 3. So the ordered pair that makes this equation true, or makes both equations true, or shows us where they cross, well, we know that the first value is x, but we don't know what y is. So what we do is we take the value of x and substitute that value into either original equation. So I know now that x is 3, so I'm going to take the value of x and I could choose to substitute it in the first equation. So I could say y is equal to, instead of x plus 4, I could say y is equal to 3 plus 4, and that would give me y is equal to 7. Or I could say, no, I don't want to use that one. Let me use the second one. Y is equal to negative x is 3 plus 10. So y is equal to negative 3 plus 10. Therefore, y is equal to positive 7. So it didn't matter which one I used. I just needed to use one of these originals to find the value of y. So y obviously is 7. So the solution to this ordered pair would be 3, 7. Let's look at problem number 8. And again, we've got y is equal to 9x minus 8. Y is equal to 8x minus 6. I know that this y, or this value for y, can replace this y. So I've got 9x minus 8 is equal to 8x minus 6. Since this 9 is bigger and I want a positive x value, I'm going to subtract 8x from both sides of the equation. I'm left with negative 8. I'm left with x minus 8 is equal to negative 6. I've got one algebraic term, two numeric terms, so I'm going to eliminate the numeric term by adding 8 to both sides of the equation. And I've got x is equal to, 8 has the advantage, it's positive, by 2, so x is equal to 2. So I'm going to just use this top equation here. So I've got 9, and where there is an x, instead I'm going to replace it or substitute the value of 2 minus 8. So I've got y is equal to 18 minus 8. Therefore, y is equal to 10. So in this case, the ordered pair where the lines cross, or the solution, would be 2, 10. All right, so let's go ahead and look at number 9. I'm trying to move this slow so that I don't make you dizzy. 9 would be y is equal to negative 2x plus 4. Y is equal to negative 3x plus 8. I'm going to take y and replace it with negative 2x plus 4 is equal to negative 3x plus 8. I want a positive variable, so I'm going to eliminate this 3x from this side and add it to the other side. That way I end up with a positive x plus 4. The 3x is eliminated, equals 8. I have one algebraic term, two numeric, so I'm going to eliminate the 4 from both sides. X therefore is equal to 4. So I'm going to use, this time I'm going to use the second equation. Y is equal to negative 3x plus 8. Therefore, where I see x, I'm going to replace it or substitute the value of 4. And I've got y is equal to negative 12 plus 8. Therefore, y is equal to negative 4. The solution to my system of equation is 4, negative 4. Then we've got 10. This time, this equation is in standard form on both lines. So when you have standard form for both lines, if you remember at the beginning, I told you that substitution is best used when you have a single or an isolated variable. So in this case, what we're going to do, pick one equation and isolate a variable. Now, here's the hint on this. It's easier to isolate a positive variable. It just makes it easier to deal with when you're substituting. So what I'm going to do is I'm going to pick this first equation because my y is positive. So that gives me really a little less to do. So I'm going to isolate x plus y is equal to 7. I'm going to isolate the y. So I'm going to add 7 to both sides of the equation. And I'm left with, oh, I meant to write x and I wrote 7. X, there we go. Y is equal to x plus 7. Now, I've isolated the variable on my first equation. So now, my second equation, where I see the value of y, I'm going to replace it with x plus 7. So I've got negative x, negative y equals 13. I go negative x minus, I'm going to substitute x plus 7 equals 13. So I've got negative x. Now remember, we've got to distribute this negative. So negative x minus 7 is equal to 13. I've got negative 2x minus 7 is equal to 13. And then I'm going to add 7 to both sides of the equation. And I've got negative 2x is equal to positive 20. We're solving now for x, so we're going to divide by negative 2 on both sides of the equation. And I've got x is equal to negative 10. Okay, that's all well and good. So now we know the value of x. So then we go back to the original equation, either one, and we substitute the value of x into either to find the value of y. Well, I'm going to use the first equation. No, let's use the second. So negative x is negative 10 minus y is equal to 13. So I've got negative multiplied by negative. So I've got 10 minus y is equal to 13. I've run out of room. So follow me. Let's go up here. Follow me here. I think that'll give us enough room. So we've got 10 minus y equals 13. Well, let's do this. Subtract 10 from both sides of the equation. And I've got negative y is equal to, well, 13 has the advantage by 3. But I don't want negative y. I want positive y. So divide both terms by negative 1. Y, therefore, is negative 3. So now I know x is negative 10, y is negative 3. That is where the values cross, or that's where the lines cross at this ordered pair. All right, we're back with an easier one. We know we're going to substitute the value of this y, which is 3x plus 6, into the second equation. That gives us 3x plus 6 is equal to negative 4x plus 9. Again, I want a positive x. So I'm going to move or eliminate this negative 4x by adding 4x to both sides of the equation. That leaves me 6 is equal to, I don't know why I keep doing this morning. 3x plus 4x is 7x plus 6 is equal to 9. I've got two numeric terms, so I'm going to eliminate the 6 from both sides of the equation, and that leaves me 7x is equal to 3. And that gives me, if we divide by 7 on both sides, x is equal to 3/7. Now, you might be thinking, Ms. Clark, oh my gosh, it's a fraction. Yeah, so what? And I just noticed a mistake that I made. Did you notice it? This should have been a negative 3x, which makes negative 3x plus 4x is positive 1x. I'm so glad I caught this. This is positive 1x equals, well, at least I did this part, 3. So divide by 1 on both sides of the equation. X is 3. Boy, that would have been a disaster. So, but we could have checked it. So I'm going to take the value of x, substitute in either equation. I'm going to take the first one, y is equal to negative 3x plus 6. Y therefore is equal to negative 3 times 3 plus 6. Y is equal to negative 9 plus 6. Therefore, y is equal to negative 3. So my ordered pair that makes this system of equations true is 3, negative 3. Now, what if I had checked it? Basically, what would have happened is if I had put this 3/7 into either one of these equations, it would have made one true but not the other true. So this kind of goes back to E1, where you're substituting values to see if both lines come out with the same value. So if I had put in negative 3 for y here, but put in 3/7 right here, they wouldn't have equaled each other. That's not good. Anyway, glad we found our mistake. 3 and negative 3. One last one and we're done. So I'm going to put, oh, this is number 11, sorry. Number 12 over here. So we've got y is equal to x plus 2. Y is equal to negative x minus 10. And guys, I know this was a rather long video, but it shouldn't take you as long. Remember, it takes me this long because I'm trying to explain what I'm doing. As you do it, you'll be talking to yourself in your head, I hope. So we've got x plus 2 is equal to negative x minus 10. I'm going to add x to both sides of the equation. So I've got 2x plus 2. These x's are eliminated, minus 10. Subtract 2 from both sides of the equation. I've got 2x is equal to, both are on the same team, so I'm going to add them together. I got negative 12. I divide by 2 on both sides of the equation. Therefore, x is negative 6. Then I pick either equation. I'm going to pick the first one to find out what y is. So I've got y is equal to, well, if x is negative 6, I simply replace x with negative 6. Add 2. Y is equal to negative 4. Therefore, the ordered pair for my system of equations would be negative 6, comma, negative 4. And this should do it for us. Yay, we made it to 82. Now what you do is go ahead and make it to 100. Talk to you later.